Okay, let's solve an example to see how we can break down these dynamics, okay, to a system of first order differential equations. Okay, you see that in the problem setup, they ask you to basically break down these dynamics, okay, and right now you have a second order dynamics here and also a first order dynamics here. You see that you have the order of the system is in fact 3, okay, because you have a second order derivative with respect to z and a first order derivative with respect to w, okay. So we want to basically break down this system to 3 first order differential equations. That's our goal, okay. So there is a way to do that, very easy way. In step 1, okay, we're going to first determine the order of the system and the number of inputs. Yes. So first determine the order of the system and the number of inputs. And the system, as we mentioned, n is the order of the system, which is basically the order of derivatives. Yes, you have a second order derivative with respect to z, and you have the first order derivative with respect to w. 2 plus 1 is going to be 3. Also, the number of inputs from the system, from the problem statement, okay, they said that the input to the system is in fact v over here, okay, and you're going to have only one input to this problem. Okay, so we are good here. Yes, we can navigate to step 2. Which we're going to set up your state and your input variables. Okay, so let us set up your states and your input variables. Input variables, yes. Note that, guys, for the states, I have a convention, okay? And in my convention, states are shown with X, okay? And if I have multiple states, I'm gonna have indices for these X's. The order of the system is 3, which means that I would need 3 states. My states are gonna be X1, X2, X3, yes? And if you guys remember, I had only one input for this system, so that's okay. My input is gonna be U, okay? Now, the easiest one here is the input because it's explicitly given to me in the problem statement that input is V to this system, okay? However, the states might be a little bit tricky. What are the 3 states? Well, look at this. Identify the maximum order derivative in your equations. Okay, so it's going to be z double dot and w dot. Okay, so identify maximum order derivatives of each family. Okay, family of z, z double dot, family of w, w dot. Yes, you go one order derivative below that maximum order for each of them. Yes, so for instance, for this guy, I can go z and then z dot. Z dot is exactly one order derivative below z double dot. Okay? And the next one is going to be z double dot. I'm not going to go there. Here again, for w dot, I'm going to go w. The next one is going to be w dot. Yes? So these guys are going to be my states. Yes? So these guys are going to be my states. Look at this. My z, z dot, and w. I needed 3 states. There you go. Yes, guys? I needed 3 states. There you go. Z, z dot, w. Okay? And this is always how we go there. Note that, guys, the order here is not important. I go with Z, Z dot, and W. Somebody goes with Z dot, W, and Z. Someone else goes with W, Z dot, and Z. You see what I'm saying? This order does not matter. Okay? The order does not matter. Now I'm going to go to the next step, step 3, which is writing down 3 first order differential equations. Look, the order of my system is 3. I need 3 first order differential equations here. Yes? So writing down n equals to 3 in my example, first order differential equations. How can I do that? Well, that's going to be very easy, yes? So let's go to a step 2, okay, and copy your states here. I'm going to copy these guys, okay, and I'm going to paste them here. And you will see in a bit why I'm going to do that, okay? So I'm going to copy and paste them here. Now, just the states, the input equation, we do not care about that one, yes? Now, let's take the derivatives of these equations, okay? And any time on the right-hand side, the maximum order derivative happens to be in the dynamics of the system, we're going to isolate it from the dynamics of the system and we're going to bring it here, okay? What do I mean? Look, the maximum order derivative in the first equation is z double dot. Do you guys agree? Yes? It means that any time z double dot happens to be on the right-hand side of my equations, I'm going to isolate z double dot from the dynamics of the system. I'm going to bring it there. Or the maximum order derivative for w is w dot. Do you guys agree? Yes? So anytime w dot happens to be on the right-hand side of those equations, after I took the time derivative, I'm going to isolate it and I'm going to bring it from the dynamics of the system. Okay? So let's go ahead and do that. The first one, I'm going to take the time derivative. X1 dot equals to z dot. Well, z dot is not the maximum order derivative for z because I have z double dot. I'm good here. Second equation, z2 dot equals to z double dot here. Yes, note, z double dot is the maximum order derivative for z. You see that? What I'm going to do is I'm going to isolate z dot, double dot from the first equation and bring it down below. Okay, so if you isolate it, it's going to be 1/2 of negative 0.8 z minus 0.4 w minus 0.2 z dot w. Okay, that's all. Let's go to the next one. I'm going to take the derivative again. X dot 3 equals to w dot. Again, w dot is the maximum order derivative for w. So what we're going to do is we're going to go to the second equation from the dynamics of the system. We're going to isolate w dot here, okay, and bring it to the other side, okay? So this is going to be 1/4 negative 3w, negative 1.5 w3, or w cubed, sorry, plus 6z plus 8v. Okay, the only that I did was I isolated the maximum order derivatives from the dynamics of the system. Okay, now I'm going to go to a step 4. Okay, in a step 4, go back to a step 3. And substitute from your states. Okay, look, in a step 2, you put x1 as z, which means that whatever z that you have in the equations in step 3, you're going to change it to x1. Whatever z dot that you have, you're going to change it to x2. Whatever w that you have, you're going to change it to x3. Okay, and whatever v that you have, you're going to change it to u. So in fact, the assignments that you had in step 2, you want to do the reverse. Yes? Okay, so let me just go ahead and copy these equations from step 3. Okay, so I'm going to copy them and I'm going to paste them here. Okay, look, whatever z that I have, I'm going to change it to x1. Look, I have z here, which is x1. And this one is a little bit thin. Okay, so I have z here. I'm going to change it to x1. What else? I have z here. I'm going to change it to x1. Okay, then z dot, I'm going to change them to x2. So z dot is going to be x2. Z dot is going to be x2. Okay, and whatever w that I have, I'm going to change them to x3. Okay, so let me just pick another color here. I think blue is fine. Okay, so w is going to be x3, x3, and x3, and x3 here. At last, I'm going to work with my input. Don't forget this one. Yes, all the inputs, it's going to change to u. Okay, at this point, guys, you notice that since you substituted for z double dot and z and w dot, you do not need these two terms here. I'm going to get rid of them. I'm going to bring these two equations here a little bit to the left to make everything nice and clean. Okay, now I'm done. I have my state dynamics. Look on the right hand side, I have only states and inputs or controls. On the left hand side, I have only first order derivatives. So in fact, the whole thing that I did was the second order system that I had it here. Okay, I break it down to a system of first order differential equations. Basically, I broke it down to 3 first order differential equations with a specific form. We call it as state space. Okay, we call it as state space or state variable equations. Now, one thing to note is that these equations are linear or nonlinear. You guys tell me. Well, I have a nonlinearity here and also a nonlinearity here. Okay, and honestly, it doesn't matter because whenever I see only one nonlinearity in the system, the whole system is nonlinear. Okay, whenever you see only one nonlinearity in the system, the whole system is nonlinear. Okay, so if you find one nonlinearity in the system is nonlinear. What is the order of the system? Well, it's going to be very easy. Why? Because in step 1, we found the order as 3. It's easier to even to look at the system and figure it out here because you have 3 first order differential equations, yes? Which means that the order of the system is exactly 3. 1 plus 1 plus 1, 3. 3 first order differential equations. Okay? And we mentioned that this system is nonlinear. Okay. In the next example, we're going to solve another example of these types.